Hi all, I'm here to present like one of the new technology introduced in like intelligent transport system, that is vehicular ad hoc networks. And one of the motivation to vehicular ad networks are like millions of people over the world are dying due to the accidents, and many of the governments are using the techniques to reduce the accident, like safety precautions in between the roads, like traffic jam signals, and like there is a ramp on the right so that. And when you're coming to the like what are the HADAC networks, it's just like a like local area network that we use to send the information like we used to like in the internet. But when coming to the special characteristics of HADAC networks, like it is used for like small area networks, so that like small kind of networks can use, like you need to send a data between the like few users. If it is like 10 or 15 users in the network, we can use HADAC networks. And it is also called VNet. And the FCC, like Federal Communication Corporation, is allocated some a definite frequency to the like vehicular HADAC networks is kind of like 75 megahertz. It is also called as distributed short range communications. Next. Here is an overview of how VNet look like. Is kind of like highway traffic road. There are some vehicles in the like. If you have an emergency unit, even like if you two cars crash, they can provide information to the next car so that they cannot collide with each other, so that they can prevent the accident. And there is not only like communication between the each vehicle, there is a communication between the road based unit and the car in between the highway, so that the radar can send information to other cars not in these highways, so they can avoid the traffic jam. So there is an example of how like vehicular HADAC look like. Next. And when coming to the vehicular HADAC networks, we use the sensor technology to transit the data between the vehicles and data between the roadside transmitter to the vehicles. We got like intervehicular communication and roadside vehicle communication. Like intervehicular communication that we see in the past diagram, so you can provide transmit the data between the vehicles in between the road, and it can send the data to the roadside base station. Next. While coming to the applications of VNet, as our friends told that like we can plan when we going to a trip, like everyone do, like when you're going to a trip, access the browse, access the for a web page, like how much time you're going to take and what are the routes we need to take. But if you install like VHADAC networks in your car, these are like the modern applications of future car that we going to be here like in 2012 or 2010. Well, coming to the HADAC networks, one more application is safety that you see, like is avoid the collision between the vehicles. And the next part will be continued by our friend Madhu. Thank you very much.
Hi, I'm here to present a presentation on how wireless technologies can be used to track a vehicle. This is called as transit information tracking. And before that, I would like to know about a report. This report is brought by technology management firm, and it says that it says about the web users. According to the report, in the year October 2007, there are 1.2 billion email users, but they predicted that by the year 2011 it would be 1.6 billion email users. And the report also says that in the year 2006, there are on an average 183 billion emails are sent each day. That is a really huge amount. And email systems are designed so that they are not only used from the computers, and they can be used from without any wireless devices like mobile phones and any other wireless devices. And for that we need WAP. WAP stands for Wireless Application Protocol, and without WAP we cannot use our internet from the mobile phones or any other wireless devices other than computers. Then how can we track a vehicle using wireless technology? A person can track a vehicle of his interest like buses or trains using wireless technology, so that he can keep on time and he can travel his tours well in advance, and he can be updated by the latest informations, and the estimated time and RMS dependencies can be derived through the internet or wireless devices. And I will explain how a passenger can track a vehicle, whether the vehicle can be a bus or a train. I'll draw a small flow chart for you. This might be the person who is interested to track a vehicle. He sends a request. From his mobile phone to the gateway computer. And this gateway computer might be using WAP services if the request is sent from the mobile phones, or else it uses just the HTML markup language. And from here, it goes to the web server. The request goes to the web server. Where the request is finally read and the response is created. The response is created at the web server, and this response is then sent to the gateway computer again, and from here it reaches the user. It might be on his mobile phone or on the computer, whatever the device he is using. In this way, a person can track a vehicle of his interest. And in the small cities like Charleston, we don't have any bus facilities, so we might be not using this technology. But in the larger cities like Chicago or New Jersey, people depend upon this technology rather than because they depend on public transportation rather than on their own cars. And that's it. And the next application will be explained by Veena.
Yeah, this is the technology of artificial intelligence actually, and this was explained by one of my friend, and I'm going to apply this to the intelligent transportation systems, and I'm going to discuss how the traffic signals can be controlled using a neural network. And here, first of all, I'd like to discuss how the operation of modern traffic signal works, and that's they work by the usual software programs which are written using the algorithms, and actually, and those algorithms are written in such a way that the signals will be operated periodically, and I mean to say the time interval between the signal change is same,